Right, I'm running my recreated organiser here, and it's currently plugged into one of these Comms Link cases. Now, this is just a Comms Link in a different form factor. Instead of a wire coming out the end, you've got connectors, and I think you can apply external power. And the reason I'm using it is that I'm running the LZ ROM here, and the code in here, in the ROM of the Comms Link, is actually a 4-line version of the code. I've got an older 1980s Comms Link that I bought years and years ago, and that's 2-line, and it just doesn't look as nice on the screen, so I found that this has got a more up-to-date version of the code. So I'm also running my Gemini, which is running the Bluetooth serial terminal, and if we go to the main menu, we'll let that come up, and I will connect over Bluetooth, and it's connected. I'll say hello, and I get the response back. So that's running in the command line mode of the Bluetooth communications. If I go here and press C a couple of times, you can see that comms is there, and that's loaded the ROM from the Comms Link. So if we go in there, we'll get some menu options from that code, and one of them is terminal. So we'll go in there. Now, over on the serial terminal, the Bluetooth terminal, I've got this toggle option. If I hit that, that sends a Control T, and what that does is turn the mode of Bluetooth connection to my code from the command line to a mode that passes traffic to and from the Comms Link software. So that is using emulation of the hardware within the 6303, the serial port, the registers and flags in registers. And as far as the Comms Link's concerned, it's just data coming in from the serial port. It doesn't really know that it's actually coming in from Bluetooth. So if I now send the hello message, so hello has appeared, so that's data coming from Bluetooth into the organiser, and then I'm presenting that data in the registers that serial data would normally appear in, and the Comms Link code doesn't know that it's not coming in from a wired connection, so it just displays the text. If I then type HI for hi, space B A C K, hi back. There's 2 A's there, I don't know why that is, key might have bounced or something. So data's going in both directions, and it's using the same mechanism. The Comms Link code will come down to send data, and it does that with a write to a register. My emulator sees that write, picks it up, buffers it, sends it off to Bluetooth, and it appears over there. Once it's pulled that data out of the register, it clears the flag, and that says that the transmit data register is now empty again, and that means that the Comms Link code will put another character in, and so on. So we can hit enter, and let's send the command, the procstat command, that's the processor status in command line mode, and just send back an A and a B and a C. So it's not polished and finished. There's obviously some problems there because I've got 2 A's in back, but as proof of concept I think that works. So it means that it looks to be possible to create a Bluetooth connection with a Comms Link. You just plug a Comms Link in the top, set it up to do Bluetooth connection to the Comms Link, and off it goes. To do wired, I need to write another bit of code, and that will, instead of using the registers for the serial port, instead of using those to talk to Bluetooth, what that needs to do is actually use them to wiggle one of the GPIOs on the Pico when the registers are read, and also, so transmit will wiggle a GPIO, and receive, when you read the received data register, that will be set up from data that has come in on another GPIO. So that's another bit of code, and that should hopefully provide the original function of the Comms Link, which is to use wired. Now, one thing about this terminal, if we come out of it, is when you're in Bluetooth mode, because it's only using the transmit and receive data registers, it's not looking at any other registers because it doesn't need to. When Bluetooth traffic comes in, you just get a string of bytes. None of these settings here are actually relevant to that data transfer. So whatever comes in on Bluetooth is presented in the data register, and it means that baud rate is irrelevant, parity and so on is also irrelevant. We're just getting bytes. So I don't know how that works with 7 and 8-bit data, but hopefully the code that's expecting 7-bit will just strip the top bit. It would be possible for my code to do something with the data that's coming in and strip the top bit if needed.